So we discuss about the data plane, SR, MPLS. We discuss about how the traffic engineering will be, how we can stack it, right? Also, we discuss about the stacking using SRh. And then we saw that the packet flow between A to D. Now we'll see that how does an IPv6 becomes a SID, right? So SRv6 is basically divided in locator, function, and argument. How does IPv6 becomes a SID? Basically, an IPv6 becomes a SID we'll see in this module. So first we'll see that an MPLS label is nothing but a number that is given by a local meaning and by the receiving device. And based on that, it will has one and only one meaning. So SRv6, so a single 128 bit, which is an IPv6 plus SRh, wherein we have 128 bit value. For example, 201 db8 00001234 4567 000000 and 000. So this is basically divided in three separate information. This is what we're talking about, the SRh. The first one is basically the locator. The second one is basically the function, and the third one is argument. So whenever we are talking about a locator, so locator is nothing but a routable part of an SRh, that what at every device advertise that. And it has basically, when an address is being processed by any device, for example, back in our example of A to D routing, previous class we discussed about that, right? When a packet will be received, transit node, where we do not have the SRv6 enabled, it's only IPv6 enabled device, that device is basically process that towards the next hop to reach to B. This is my transit node where it is processed to the next hop to the B, right? But B here is the device which advertise that locator. And once it reached to the destination to B, that means we need to process the next part of it, which is called as function. So when my packet reach to B, it will process the function. And here the function tell us about what function we need to perform when a packet is being processed, means when we reach to the destination, whether it will forward, and based on the function it will tell us. So function is basically a specific information that the destination segment should perform, whether we need to go to the next hop like an adjacent SID, whether it is a VPN, L2 VPN or L3 VPN, right? So whether we need to pass the traffic to a specific next hop. For example, source is sending a packet to B, right? Back in same example, transit node processed, and then it reached to B. Now, whether B will send it towards the white next hop or the gray one, that depends on the function will tell us whether which next hop to forward the packet toward the next SRv6 router. And then if it is a VPN, then it will tell us whether it's a VPN, L3 VPN or L2 VPN. We'll see that in our next modules. We'll discuss that. Next is argument. So argument is something which offers more fine granular information to be processed, right? But in practice, in general, it is rarely being used, and everything is, we set it as 0000. It's not a mandatory division like a function and a locator that we have. And the use case for argument is EVPN, ESI filtering. So what we discussed so far, we discuss about the locator, we discuss about argument, we discuss about functions here. So an SRv6 address, 128-bit address, has been divided in three parts. That three parts create some information. First part is basically the locator, which is the routable part of it to reach the device. Once we reach that device, Whether what to perform, what kind of function to perform, will tell us by the function and argument, which will give us a fine granular information. So next we'll see that this SID block. So based on the SID block, what all things that we can do and how basically it will advertise that. Thank you.